In this lecture of signals and systems, we are going to see the shifting operations of the continuous time signal. Shifting operations of the continuous time signal is of two types, time shifting and amplitude shifting. In this lecture, we will only understand the time shifting operation of the continuous time signal. We know that continuous time signal or CTS is a function of independent variable time t and is defined for all the values of the independent variable t. Continuous time signal can be represented by xt, where x is the dependent variable and t is the independent variable. Time shifting operation of a signal is a signal processing operation that delays or advances a signal in time by a real positive constant k, or the variable t in the original continuous time signal xt can be replaced by t plus k. Mathematically, it can be shown as time shifted version of the signal yt is equal to x of t plus k, where k cannot be equal to 0. Let's consider a system which does the time shifting. Then input to this system is the continuous time signal xt, and output of this system will be continuous time signal yt, which is the time shifted version of the input signal xt, or yt is equal to x of t plus k. Based on this value of k, time shifting operations can be of two types, time advance operation and time delay operation. Time advance operation. Again, time shifted version of the continuous time signal xt can be expressed as yt is equal to x of t plus k. Time advance operation of the continuous time signal will take place when this k is greater than 0, and if this condition is true, then k will have the value range from greater than 0 to infinity, or the possible values of k will always be positive and greater than 0. Mathematically, this can be shown as yt is equal to x of t plus k, where k is in between 0 and infinity. This time shifting operation only changes the time axis, but no changes takes place in the amplitude axis. Time delay operation. Again, the time shifted version of the continuous time signal xt can be expressed as yt is equal to x of t plus k. Time delay of the continuous time signal takes place when this k is less than 0. If this condition is true, then k will have the value from minus infinity to 0, or the possible values of k will always be negative and less than 0. Mathematically, this can be shown as yt is equal to x of t plus k, where k lies between minus infinity to 0. When k is equal to 0, no change in time axis or no time advance or time delay takes place. Let's see an example where time advance operation takes place. We know that the condition for the time advance operation of the signal xt is yt is equal to x of t plus k, where k lies between 0 and infinity. Let's say k is equal to 2. Now we have to plot the signal yt is equal to x of t plus 2. At first, we will take the signal xt and we will make the table for observing the different values of the signal xt at different time instants. Now we will make a table for observing the different values of the signal xt at different time instants. When the time t is greater than or equal to minus 1 and less than 0, then the value of the signal xt is equal to 1. When the time t is greater than or equal to 0 and less than 2, the value of the signal xt is equal to 2. When the time is equal to 3, then the value of the signal xt is equal to 0. Now we have to calculate yt, which is equal to xt plus 2, as yt is equal to xt plus 2. So this is a time advance operation. Here we have to advance the signal xt by 2, or simply we need to shift the signal xt to the left by a value of 2 for every time instant in the time axis. To shift the signal to the left by 2 time units, we need to subtract 2 from each value of the time interval for the signal xt. So if we subtract 2 for the time interval of t less than or equal to minus 1 to 0 for the signal xt, then new time interval for the signal yt will become t less than or equal to minus 3 and less than minus 2, and value of the signal yt will be same as the value of the signal xt, or yt is equal to 1. Similarly, we need to subtract 2 for the time instant t is greater than or equal to 0 and 2. So the time instant for the signal yt will become t less than or equal to minus 2 and less than 0, and value of the signal will be same as the value of the signal xt, or yt is equal to 2. And for the time t is equal to 3 for the signal xt, the time instant for the signal yt will become 3 minus 2 or 1, and the value of the signal yt will be 0. So this is the time advanced operation of the signal xt, where xt is shifted to the left by a value of 2. If we compare the two waveforms, then we can see that the time axis of the signal yt is shifted to the left compared to the signal xt, or time advancement of the signal xt takes place. Now if we look at the two waveforms, then we can see that for the signal xt, time axis exists from minus 1 to 3, but for the signal yt, which is equal to x of t plus 2, the time axis is available from -3 to 1. In this case, we have subtracted the time axis of the signal xt by 2 and no changes takes place in the amplitude of the signal. So for the time advancement of the continuous time signal, we just need to subtract the time axis of the original signal by k for every time instant, and no change should take place in the amplitude axis of the original signal. Now let's see the time delay operation of a continuous time signal. Now again, the condition for the time delay operation of the signal xt is yt is equal to x of t plus k, where k lies between -infinity to 0. Let's say k is equal to -2. So we have to plot the signal yt is equal to x of t minus 2. Again, we will make the table observing the different values of xt at different time instant. Like previous, on the time t is greater than or equal to -1 and less than 0, the signal xt has the value of 1, and on the time t is less than or equal to 0 and less than 2, then the signal xt has the value of 2, and on the time t is equal to 3, then the signal xt has the value of 0. Now we have to calculate the signal yt, which is equal to x of t minus 2. As yt is equal to x of t minus 2, this is a time delay operation. Here we have to delay the signal xt by a time instant of 2, or we need to simply shift the signal xt to the right by a value of 2 in the time axis. To shift the signal xt to the right by 2 time units, we need to add 2 with each value of the time interval. First time interval of the signal xt, which is t less than or equal to -1 to 0, if we add 2 with this time interval, then the new time interval for the signal yt will become t less than or equal to 1 and less than 2, and the value of the signal yt will be same as the value of the signal xt, or yt is equal to 1. Similarly, we need to add 2 with the next time interval of the signal xt, which is t less than or equal to 0 and 2 for the signal xt, and new time interval for the signal yt will become t less than or equal to 2 and less than 4. And the value of the signal yt will be same as value of the signal xt, or yt is equal to 2. And finally, the signal xt ends at t is equal to 3, which will become t is equal to 5 for the signal yt, and the value of the signal yt will be same as xt, or yt is equal to 0. So this is the time delayed operation of the signal xt, where xt is shifted to the right by the value of 2. If we compare the two waveforms, then we can see that the time axis of the signal yt is shifted to the right compared to the time axis of the signal xt, or the time delay operation of the signal xt takes place. If we take a look at the two waveforms, then we can see that for the signal xt, the time axis exists from -1 to 3, but for the signal yt, which is equal to x of t plus 2, the time axis is available from 1 to 5. So we can say that in order to obtain the signal yt, which is the time delayed version of the signal xt, we have added the time axis of the signal xt by 2 time instant, but no changes in the amplitude axis of the signal took place. So for the time delayed version of the continuous time signal, we just need to add the time axis of the original signal by a value of k, and no changes should take place in the amplitude of the signal. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.